So in NCRT, the name is electric field and charges. Okay. So that is nothing but electrostatics itself. So electro means charge. Okay. Statics means rest. So charge at rest, we are going to study. The first thing is what is charge? It's a property of material. Okay. So we denote charge by Q and its unit is coulomb. Okay. So and the charge has some property. The first property is charge is quantized. That is, the charge will be multiple of charge of electron. And charge of one electron is 1.6 into 10 to the power minus 19 coulomb. You guys know this, right? Mass of electron is 9.1 into 10 to the power minus 31 kg. Okay, quickly I'll revise and we'll start solving questions. So then we talk about Coulomb's force, Coulomb's law. What it says, Coulomb's law. So like if we have two charges, Q1 and Q2, we have two charges Q1 and Q2, and they are separated by a distance r vector. So the force between them is given as k q1 q2 by r square into r cap. Okay, the direction of force will be along the line joining itself. Okay, so like friction, right? We saw that if on the block it is acting like this, on the surface it will act like this. So net force is 0. Similarly here on Q1 the force will be like this, on Q2 the force will be like this if they are of opposite sign. If they are of same sign, the force on Q1 will be like this and the force on Q2 will be like this. So net force on the system is always 0. Okay guys, this is the formula for Coulomb's law. So now if we have system of charges, like let's say we have Q1, Q2 and Q3 and they are kept on an equilateral triangle, then how will you find the force on any one of the charge? If I say force on Q1 is how much? So what you do, first you calculate due to Q2. So let's say the side is A. So on Q1 due to Q2, how much will be the force? K Q1 Q2 by A square. Correct? So what you have to do is like you have to take this as x-axis. Anything you can take x-axis, this as y-axis. If it is an equilateral triangle, all angles will be 60 degree. Correct? So what will be the direction of this force? So since this angle is 60 degree, so this horizontal component will be how much, guys? This is the total magnitude of the force. In horizontal, cos 60 degree. I cap plus k q1 q2 by a square cos sine 60 degree j cap. So this is done with this force. Now, due to Q3, what will be the force? You have to add in this only. K Q1 Q3 by A square, and the force is acting like this, correct? Again, this angle is 60 degree. So along this x-axis, it will be minus cos 60 degree I cap plus K Q1 Q3 by A square sine 60 degree j cap. Any issue? Any doubt here?
No, sir.
Simple, right? Simply I am writing the force and taking its components along x and y axis and just summing up. So this is a vector form of net force on Q1. Okay. Okay, guys. So because in vectors I taught you how to do components, that's why I'm going with only that method. You can actually solve this with other method also, because Q1 is here, no? Due to Q3 the force will be like this, due to Q1 the Q2 the force will be like this, and angle between them is 60 degree, correct? So again you can use that formula, under root F1 square plus F2 square plus 2 F1 F2 cos 60 degree. You can go like this also, net force. Okay, you can go with any method, but this making component is more suitable, which gives you both direction as well as magnitude. In I cap J cap form you can easily write, correct? So what is K here? It is 1 by 4 pi epsilon naught. Okay, what is the value of K? 9 into 10 to the power 9. What is the value of epsilon naught? Can anybody tell me the value of epsilon naught?
8.82852 into 10 power minus 12.
Okay, this is the value of epsilon naught. Okay, again this for any, this is for vacuum, for any medium this can be written as 4 pi epsilon naught into epsilon naught r, where epsilon naught r is the relative permeability of the medium. So for vacuum epsilon naught r equal to 1, and for water epsilon naught r is 81. Okay, so you remember these two things. And for metals epsilon naught r is infinity. Okay, quickly note it down, I will go ahead. Shall I go ahead?
Yes, sir. Yes, sir.
So let us do one simple question. Don't waste much time here. So let us say I have Q here, minus Q here, and then minus Q here, and plus 2Q here. Okay. I want to find what will be the force here at the center if I keep there one charge Q. Okay. So first what you have to do is, this is 90 degrees, so these are kept on the corner, so 45 degrees. So first thing what you have to do is, if you want to find it in vector form, you have to join all the lines. Okay, first you join it. Okay, then see this and this are of negative sign, so the force on this will be towards this. Okay, okay, due to plus 2Q and this Q both are of same sign, so it will be away from Q, it will try to push the Q, so the direction will be like this, correct, along this line. Okay, and then if I see minus Q, again it will try to pull it towards it, so it will be like this. Okay, then this 2Q is done, minus Q is done, plus Q is done. Okay, so 3 4 this is done. Okay, this is due to plus Q, it will try to push it, so the it will be in this direction. So then what you have to do is, you draw x-axis, y-axis. Okay, this is the best way you can solve this. You draw x and y, then you draw. Okay, one is this force, what is its value? K cube square by, let's say this distance you can calculate, right? All are a, you can calculate, this is root 2 a by root 2. Okay, a by root 2 ka square. Let us say for now I am saying this is r, so r square. You can calculate that r. This first force we have drawn. Okay, let's say it is F1. Similarly, all forces you can write. So one more is here. Let us say it as F2. You write what is F1, what is F2, what is F3, and what is F4. You write like that. Okay, then we have one more force here. Okay, and then we have one more force here. Okay, then see the angles. Okay, this is 45 degree. Correct, no? Because this is 90, this is 45, this is 45. All are 45 degree only. So do the component of each force. This here this is F1, F2, F3, F4. Do the components. This will be how much? F1 cos 45 degree. Okay. This will be F1 sine 45 degree. Similarly, you do here F4 sine 45 degree. Here F4 cos 45 degree. Similarly, you do all components and add net force will be you add all x components I cap you do plus all y component j cap you do. You understood? Guys, understood?
Yes, sir.
Any doubt?
No, sir.
Okay. All right. So let us go ahead. Okay. So now we'll see electric field. From force only you can expect those questions. Okay. All right. So one second, guys. Okay. So electric field, now we'll see. What is electric field, guys? Electric field is nothing but, electric force per unit charge. Okay. Electric field is defined as how much force is experienced by a unit charge. So you can write force is equal to Q into E also. Okay. So formula for electric field is KQ by R square. Okay. KQ by R square. So we have some standard results that we need to remember, that electric field due to a finite wire. Okay, let us say there is a wire, okay, finite length rod or wire. Let me draw it neatly. Okay, so what's happening? So let us say I have a rod, okay. So one rod only, okay, guys. Finite length and it is charged positively of linear charge density lambda. Charge density means charge divided by length. Okay. So how much charge is there in this length L of the rod? So per unit length, how much charge? So this is charge density. So there the question arises is, so at a point X or R, what is the electric field? So always if we solve this, we'll get one electric field which is parallel, okay, parallel to the rod, one electric field which is perpendicular to the rod. Okay, two electric fields we get if this angle is not different. Okay, theta 1 and theta 2, if these angles are different, then the formula for the perpendicular component is given by k lambda by r, sine theta 1 plus sine theta 2. Okay, and for parallel component, for this component the electric field formula is given by k lambda by r into cos theta 2 minus cos theta 1. Okay, these two formulas you have to remember. Shall I go to next?
1 second, sir.
Yeah.
Done, sir.
Done? Okay.
Yes, sir.
So now, so if the wire is infinite, okay, instead of finite length, if it is a infinite, then at a distance r, the electric field will be always perpendicular. We don't get any parallel electric field, and the formula is given by 2k lambda by r. Okay, 2k lambda by k, you know what it is, and lambda is nothing but total charge divided by total length. Okay. For semi-infinite rod, like for example, it is not going to infinity at one end, but one end is going to infinity. So what is the electric field here? So here you will get both perpendicular, E perpendicular and E parallel, both you get. Okay. So the value of E perpendicular will be k lambda by r, and this is r. Okay. E parallel is also k lambda by r. Okay.
Done, sir.
Done. Okay. So for one more important formula, I'll give you that if you have a arc, okay, and the radius r, and this arc is positively charged, okay, and this radius is r, we want what is the electric field at the center. If this angle is phi, okay, then the formula you have to remember is the electric field at the center. Of course, it comes in this direction, and that is given as 2k lambda by r, and r is the radius, into sine phi by 2. So phi, if I make it a semicircle, what will be my phi? 180 degree, right? So you just put phi equal to 180 degree. Here in this case, whatever the phi they are given, just put it. If it is complete circle, then theta is 360 degree. You put 360 degree. Okay.
Yes, sir.
Yeah. So for complete circle, electric field, if I put phi is equal to 360, it is 360. That is how much? 180. So sine 180 is 0. So for complete circle, you will get 0. For semicircle, you put you will get 2k lambda by r in the downward direction, like this. Okay. Simple, right? One formula can solve many questions. Don't want to derive it because we don't have much time. Okay, guys. Okay. Noted.
Yes, sir.
Okay. So let's go ahead. Okay, so now what is left is there is what we call electric field and dipole. Okay, let's make that a separate class. As of now, whatever we studied, let us try to solve some previous year questions. Okay. So just let me Google some questions. Here is the Chrome. Yeah. Okay. So okay guys, see, C1 C2 are two hollow concentric cubes enclosing charges 2q and 3q respectively, as shown in figure. The ratio of flux I will teach you later. Force between two point charges Q1 and Q2 placed in vacuum at a r centimeter apart is F. Force between them when placed in a medium having dielectric constant 5 at r by 5 centimeter apart will be. See guys, can you solve this? What they are saying is, when there are Q1 and Q2, like this situation, you draw the diagram. First the distance was r, second the distance became r by 5, and here the dielectric constant, how much they have gave? The dielectric constant is 5. Okay, so yeah, so here the dielectric constant was 1 because vacuum, so here the dielectric constant is 5. Okay, dielectric constant means epsilon or r. Okay, epsilon or r. So here what will be the force? In first case, it will be k q1 q2 by r square, which is equal to 1 by 4 pi epsilon at r into q1 q2 by r square. Second force, this is, let's say, F1, this is F2. So here 1 by 4 pi epsilon naught into epsilon naught r is 5 into q1 q2 by r by 5 ka whole square. Let us simplify it furthermore. 1 by 4 pi epsilon naught into 5 into q1 q2 by r square into 5 will go up 25, 5 ones are 5 5s are. So 5 times you are getting, right, this, because here epsilon naught r is 1. So F2 is 5 times F1. So initially if the force was F, then when you go into medium of 5 and if you decrease the distance by r by 5, the force will become 5 times. Okay guys, any doubt?
No, sir.
Very good. So it will be 5 times F. That is the correct answer. Two charges Q, 3Q are separated by distance r in air at a distance x from charge Q. Two charges are there, okay? Q and 3Q are separated by a distance r in air at a distance x from a charge Q. The resultant electric field is 0. The value of x is. The value of x is. So let us try to solve this. Okay. So you have Q and 3Q. Okay. They are separated by a distance r. Okay. Now they are saying that x distance from this Q, the electric field is 0. If this is x, guys, what will be this? This length? R minus x. Correct? What will be the electric field here due to this Q? It will be kq by x square. And this should be equal to electric field due to 3q. Then only the net electric field will become 0. K into 3q by r minus x whole square. Kq got cancelled. 1 by x square is equal to 3 by r minus x whole square. So let us solve it. R minus x divided by x whole square equal to 3. R minus x by x equal to root 3. So from here, let us solve. R minus x is equal to root 3x. So r is equal to root 3 plus 1 times x. So x is equal to r divided by root 3 plus 1. Any doubt?
No, sir. No, sir.
So r divided by root 3 plus 1 should be the answer. Okay. A particle of charge minus q and mass m moves in a circle of radius r around an infinite long line charge of linear charge density plus lambda, then time period will be given as. So they are saying there is a charge, okay, minus q and mass m moves in a circle of radius r. Okay. Around an infinitely long line charge of linear charge density plus lambda. Then time period will be given as. So this is bit difficult question. Let us see what it is. We have to just go through the basics. So there is the one circle, okay, of radius r, and there is one charge minus q which is moving around this circle like this, okay, and there is one around a infinite wire means like there is one wire, okay, inside I'm showing means it is going inside and it is very much infinite. So we know that due to that infinite wire, there will be electric field at this point because this is a negative charge. So the electric field will be pulling it like this. So what will be the force? It will be electric field times the minus q, correct? So the force is E times minus q. So if it is E times minus q, then E we know it is 2k lambda by r, correct? We know, then into minus q. So it is minus 2k lambda by r into q. Any doubt till here?
No, sir.
No? Okay, all right. And you guys know that the here, since it is moving in the circular motion, the electric force will provide the centrifugal force, that is mv square by r. Okay, understood? Or you can directly write this is equal to m omega square r. Okay, so from here we'll get omega, right? We'll get omega. So what is the omega from here? Let us try to solve it. Omega is equal to under root 2k q lambda divided by r square into m. Any doubt here?
No, sir.
So once omega you got, time period will be 2 pi by omega. So it will be 2 pi under root r square m upon 2kq lambda. Okay. So let us simplify it. So time period is equal to 2 pi under root r square m into 4 pi epsilon naught divided by, because k is 1 by 4 pi epsilon naught, no? So it will go up 2q lambda. So this should be the answer. 2 ones are 2 twos are. So it will be 2 pi epsilon naught m r square divided by q lambda. So where is it? Okay, so r will come out anyways. So see, wherever 1 by 2 pi is there, those are wrong options. So B and C are wrong options. Then either it can be D or A. So how to check? Since here R cube is coming, so we were not getting anywhere R cube. So the answer should be D option, right? What we are getting in our solution? Yeah, so R if you take out, no, from here it is 2 pi R into under root 2 into M into pi epsilon naught divided by q lambda. So is it matching, guys? Yeah, in k, in terms of k only they given, so no need to put any that thing, right? So let us check. Yeah, correct answer. So they did not put k is equal to 1 by 4 pi epsilon naught. Okay, guys, simple, right?
Yes, sir.
Understood? So that is done. The electrostatic potential due to an electric dipole at distance r varies. As this I haven't covered, I will teach that. Electric field is given, the electric flux that I will teach later. Two charges are situated at point this respectively. The electric flux I haven't taught, right? This also I have to teach. This also I have to teach. See this question, guys. A 10 microcoulomb charge is divided into two parts and placed at 1 centimeter distance so that the repulsive force between them is maximum. The charges of the two parts are. So what you have to do is, so see what they are saying, there is a total charge of 10 microcoulomb and it is divided into two parts. Let us say one part is Q and another part is 10 minus Q. One second, guys. Okay, so you can assume that one charge is Q and another charge will be 10 minus Q. So what will be the force? Force will be K Q into 10 minus Q by 1 centimeter. They said 1 centimeter means 10 to the power minus 2 meters square. Okay, so now they are saying this force is maximum, right? So first to see what is it coming. K into 10Q minus Q square by 10 to the power minus 2 whole square. If the force is maximum, then dF by dQ should be equal to 0, correct? We differentiate it. Just differentiate this part. Rest is constant. So 10Q minus Q square is F. You differentiate dF by dQ. 10 minus 2Q is equal to 0. You do. You are getting what? 2Q is equal to 10. Q is equal to 5. So they are 5 microcoulomb and 5 microcoulomb. Okay. Any doubt?
No, sir.
Okay. So like this you have to do. So 5 and 5 should be the answer. Okay. They have did a long process, but it's very simple, right? So can you guys practice some questions today? Electrostatics. In next
Yes.
class, in next Sunday or any one of the class, I'll finish the chapter off. Okay.
Okay, sir.
Then
Yes.
then I can teach you current electricity, then I can teach you capacitor, then magnetism, modern physics, and mostly we'll be done with class 12th. Okay, it's easy, don't take much stress, solve as many questions as you can, and if you are having time, just practice other chapter questions also and bring doubts to me. Okay guys?
Yes.
Okay then, see you then, all the best, bye.
Bye.
Thank you, sir.